Hi everyone. This is my final project, GAN for fashion image generation conditional on text description. So why I do this? What is the motivation is that GAN has a tremendous application. Uh, right nowadays, like the photo editing and the computer ad design, and also especially for the designer or creator, the fashion GAN is very useful because they can like rapidly regionalize their and modify their ideas, or also share the idea with the others more easily, just like visually share the idea. So yeah, that's the motivation. Uh, the difficulty for this project is that first, uh, it's very hard to capture the detail in the original text description if we use the traditional LSTM. Uh, yeah. And the second difficulty is that to train again to generate a high resolution photorealistic image from the text description is very hard. So yeah, that's the introduction. And let's go to the dataset. The dataset is called Fashion GAN. I downloaded it from ECCV workshop. Uh, it's a very big dataset. Uh, the total number of image is more than 300,000. And here we have uh, 78K items. So each items have multiple posts. If you see on the left, so which is same item but for four posts, and so which means several image will share one text description. So the image resolution is very high, which is 1360 by 1360. And in total, we have 48 category. Uh, the descriptor length is more than 30 30 words. I mean, for each sentence. So that's a very long and very detailed description for each single items. So the challenge here is that is basically is in two manifold. First is that the image must be realistic, right? And the second is that the realistic image must matching their text description. So this is the two tasks we keep in mind. And the whole architecture here, I'm just following the attention GAN. So attention GAN is a paper recently published in CVPR this year. It has two components. First is called attentional generating network, which draw different sub-region of the image by focusing on the word that are more relevant to the sub-region being drawn. So basically, it's try to build a relation between image sub-region and a word in a sentence. So that which is a much more fine-grained correlation. The second component is deep attentional multimodal similarity model. Basically, this model is trying to compute the similarity between the generated image and the sentence. And this module also has two parts. It has a text encoder, which is a bidirectional LSTM that extracts semantic vector from text description. And another is the image encoder, which is just a 3x3 convolutional neural network, which maps the image into a semantic vector. So yeah, that's it. And here you see the loss function is in twofold. The first part is LG. LG is the loss function for the uh, different discriminate no, sorry, different generator, and also there's a we use the similarity between the generated image and the text descriptor as a constraints. So you see here the LG plus uh lambda LDAMAS. Yeah, that's it. So yeah, let me show some result. Uh, so here the first row, in this example, in this training result, we're trying to learn the similarity matrix between the image and the text. And you see, uh, where there is a highlight in the image, correspondence to the text described it. That's it. And after we train this similarity matrix, we directly train the attention GAN, and this is the result. And this is some more result based on the algorithm. It has two stages. So first stage is just some rough result, and then the second stage is a fine grain generation. So which get a much more high resolution image. And from the result I get, I found that they are realistic enough, and also the object is quite matching the text description. So yeah, that's pretty good. So in the summary, uh, I implement a conditional GAN generated realistic fashion photo based on text description, and use the attention generating model to build a relationship between the specific word sentence and the image region. And so here there are two stage refinement of product high resolution outputs. So for the future work, I mean we try to uh, generate even higher resolution image. For example, 12018 by 12018, and also maybe like we can do something like reversed, like get the image and try to transfer image into the text caption. Yeah, that's it. Thank you.